Well, hey, ladies and gentlemen, I'm going to go over briefly questions 29 through 33 on our stoichiometry test review. So we started off, one of the biggest things of stoichiometry here, let me zoom out. You've mastered between grams to moles, moles to molecules, and moles to number of liters using the MVP triangle. What stoichiometry is comparing what I call over here, using the MVP triangle. We're always starting with the given, and then we need to connect the given chemical to the chemical we're trying to find using the mole to mole ratio. And it's always going to be the mole to mole ratio from the balanced equation. You're looking for the moles of the chemical you're trying to find divided by the moles of the chemical from the given. Now that's in the balanced equation. You always have to look at that balanced equation to get that ratio. So the first part here, let me get that out of the way. So the first part for number 29 here, so we've got this, and the important part is when we're setting up the ratios here, we want to convert C2H2 into CO2. So this is your given, and what you're trying to find here, this is what you're trying to find. So the mole ratio that we turn into a fraction for stoichiometry is always going to be what you're trying to find, the moles of what you're trying to find, divided by the moles of what you're given, F over G. So our balanced equation here today, I guess we can see it there. So this is our balanced equation we're looking at. So since we're trying to find CO2, there's 4 moles of CO2. I'm just going to put the numbers, I'm not going to write it all out. And the chemical we're given was C2H6. The coefficients are what we're focusing on there, over 2. Now you could reduce that to 2 over 1. I'm not going to do it for the rest of these. So let's see. B. If you're trying to find water, there's 6 moles of water in the balanced equation, and the given chemical is C2H6, and there's 2 moles right there. And then let's see, for C here, we're trying to find CO2. There's 4 moles of CO2, and since we were given, in this case, O2, that'll go on the bottom. Now, I'm not going to go through the rest. Oh, heck. Let's see, it's pretty easy. H2O, there's 6 of them. We were given that one, 7 moles of O2. On this one, we want to find C2H6. There's 2 moles in the balanced equation, and there's 7 moles in the balanced equation for O2. So it's these mole ratios that let us convert one chemical into another, and that's why the concept of the mole is so important. And let's see, we've got 7 moles of O2 and 4 moles of CO2. Let's see, 7 moles of O2, we were given 6 moles of water. So these mole ratios are really important in the heart of doing stoichiometry. Well, let's see, O2 is what we're trying to find, so there's 7 moles of that, and there's only 2 moles of C2H6. And when you're doing your stoichiometry problems, I'll go over that in a moment, but it's always good to label what you're given and finding up there. And lastly, there are 6 moles of water, and let's see, we were given CO2, 4 moles there. So the next one here. Now in this particular problem, now I'm not going to go through and do the whole thing, I'm just going to get you set up for these. We've got our balanced equation, and let's see, we're looking for moles of Fe2O3. So that's what we're trying to find. Please get these set up. This is from the balanced equation. I'm going to label this find, and we're looking for moles. So I'll just put, you're going to try to find moles of this. The given, we've got 2.4 moles of O2, so this is the given. So now you're just going to do the given over 1, and then just like we practiced, we're trying to find this. You're going to put your 2 moles for the mole ratio on top, and then you got to divide it by the 3 moles of O2. And this was what? Moles of Fe2O3. So for this one, since we're going moles to moles, it's just a real short, this is all we have to do. This problem over here, same thing. Now our given, I'm going to erase this, is Fe. So there's 4 moles of Fe. So when you go to set this up, you always want to be able to cancel this with moles of Fe. Make sure I'm not off the page. And when you look at the balanced equation, there's 4 moles of Fe in the balanced equation. We're still trying to find Fe2O3. You got 2 moles of Fe2O3. You can do your math there. Okay, for number 31, we're trying to find liters of CO2. So circle this, find, and liters. Labeling your balanced equation with the find really helps you out in the mole ratio part when you come to it. Our given over here is going to be liters of O2. So I'm going to circle this over here. This is our given for this problem. Now, little trick here. This would normally be a full stoichiometry. You're starting here at liters, and you would have to divide by 22.4. Then you're going to multiply it by the mole ratio fraction. But then you're going to multiply to change it back into liters by 22.4. So you end up, the 22.4 is you're going to be able to cancel. So on a liters to liters problem, all we need is the given times the mole ratio. And since there are 7 moles of O2, and we're trying to find CO2, there's 4 moles of CO2. This is how you set that up. Now, if it's really bugging you, okay, you can squeeze in. You had to divide by 22.4 liters, but then over here you would end by multiplying by 22.4 liters. Those completely cancel each other out, and you're just going to have 1.4 times 4 divided by 7. Over here now, for the second part, okay, we're looking for liters of C2H6. So now I'm going to erase the old find and label this. This is the find. Once again, we're starting with liters and ending with liters. So all we have to do is the given over 1, and then set it up the mole ratio. Since we have C2H6 over here, we want the moles of 2 moles of C2H6, and we're trying to find CO2. We're still trying to find that, 4 CO2s. So you're going to have this number times 4. Actually, you could reduce this down to 2, so it's going to be that number times 2. Okay, for number 32, let's see, how many grams of this chemical? So we're trying to find this, and it's grams, and both of our givens are in grams. So now you're going to have to do a full stoichiometry conversion. Okay, you're starting here. You're going to have to divide by the molar mass of the chemical, do the mole ratio, and then you're going to have to multiply by the molar mass. And you can't skip a step here. You've got to do the full conversion here. So the first step is, on this first problem, this is what we're given. So you need to look on the periodic table and find the molar mass. I'm not going to fill it in here, grams of Ti. You just look on the periodic table. Titanium's right there, round it off. And then that'll be that many grams in 1 mole of titanium. Then we got to set up the mole ratio. Okay, we want the find over the given. Hail sneezer. Okay, pardon me. So we're trying to find this chemical. So there's 1 mole of it, 1 mole of Ti3N4. The given chemical was titanium, so there's 3 moles of titanium. And then what you're going to have to do, let's see, these will cancel out. Now we need to know the molar mass of Ti3N4. So 1 mole of Ti3N4 is going to be a certain number of grams of Ti3N4. So you're going to have to do titanium's mass times 3, and then nitrogen times 4. You're going to have to do your own molar masses. And on this problem over here, we've got same kind of thing. We're starting with grams of N2 this time. So the only major difference on here besides doing the molar mass is you'll have to divide by the molar mass, grams of N2. Now be careful, there's 2 of them. Will be 1 mole of N2. And our mole ratio, since we've got moles of N2, we've got 2 moles of N2 in the balanced equation. And up here, that'll be 1 mole. Now, oh wait, I'm sorry, my mistake. We need the moles of what we're trying to find. We're still trying to find this, and there's 1 mole of Ti3N4. And then you're going to have to, it ends the same way. You're going to have to multiply it by the grams of Ti3N4. All right, lastly, number 33. We're looking for molecules of NH3, so we're looking here. I'm going to label for molecules. We're going to have to use Avogadro's number. Molecules, not moles, molecules. I misspelled molecules, sorry. So our given is 4 moles of H2. That's kind of nice. It's already at moles, so we just need to look up here. We've got 3 moles of H2. That's moles. And we're trying to find NH3. There's 2 moles of NH3 in the balanced equation. And since we want to change it to molecules, you need to multiply it by Avogadro's number. It's 1 mole of NH3. So there you go. What's nice over here, since this is starting with molecules, kind of the same thing's going to happen with liters. We're starting with molecules, so we have to divide by Avogadro's number, multiply by the mole ratio fraction, and then we're going to multiply by Avogadro's number. Those two cancel out. So all we really need is the given multiplied by the mole ratio fraction. In the balanced equation, keep going off the page, sorry, zoom out a little. We have 1 mole of N2, sorry about that, 1 mole of N2 in the balanced equation. We're still trying to find NH3. There's 2 moles of NH3. That's moles. Okay, so there we go. You just do the math yourself, and done. Signing off.